Okay, now we're going to do the same thing. Let's see what happens if I put this plus 1 in here and find out what happens. So try and do it yourself and then look at the answer on the video. Okay, so by remembering my unit circle values, I know that these are all my values of cosine around around the multiples of 90. Well, what this function is telling me to do is to take our cosine function and now add 1 to it. So what does this do to everything? So if I add 1 to 1, it's 2. Add 1 to 0, it's 1. That would be 0. This would be 1, and that would be 2. Let me erase this so this is a little bit cleaner. So that's 2. So now let's go ahead and graph this. Let's make this just a little bit bigger. And I'm going to put this guy as 1 right here, and this guy is negative 1. So then that means if I'm graphing this function at 0 degrees, x is a degree measurement. So I guess technically in those past videos I should really do this, but hopefully it was assumed that was degrees. So at 0 degrees we're going to be at 2. 0 degrees, 2 is that point. I'm going to stop writing the coordinates here. 90 is at 1. 180 is at 0. 270 is at 1. And 360 is at 2. And I do my best to kind of make the points that are at the same height. Look good. Okay, so here's what we got. We got what looks like our cosine function, and it's looking okay. Looks like that guy that we've seen in the past video. So now I'm going to go ahead and in red I'm going to graph this guy. So what are we noticing about the change in the graph? Well, it looks as if we're shifting up 1, which we are, and that's what that number is going to tell us to do. The graph moved or shifted up 1 unit. And I find sometimes, we're discovering this, but I'm going to go through in the next few videos, rather than plotting all of these points and evaluating the function for certain values, I kind of graph the original one and make the change based on the original, and that's what I like to do. So in this video I'm going to continue along. We have a standard form. I'm going to have a Desmos interactive video associated with this that you can review to see how these graphs change. And I'm actually going to change this a little bit. I don't want you to use the way that this is set up. Okay? What I'd like for you to use is this. Y is equal to a sine of x minus b plus c. Okay? There's one type of change that we don't really talk about, so I'm not going to include it. So a is equal to a vertical stretch or shrink, right? B is a shift left or right, and C is a shift up or down. Okay? So those are what each one of those letters does. So for example, if I had y is equal to 2 sine of x minus 40 degrees plus 3, I should be able to go through this and say, okay, a is equal to 2, so it's going to stretch vertically by 2. B, well, B is 40, right? And so we kind of look at this idea, so we do x minus 40 is equal to 0, and that tells us that this b value is equal to 40, so we're going to move, or just draw an arrow right 40 degrees. And c is equal to positive 3, so we're going to move up 3 units, and that's what we're doing. Okay, so in the next video, I'm going to just run through a bunch of examples where we're finding, oh, okay, Just by looking at the equation, the graph was stretched vertically by 2, it shifted right 40 degrees, and it shifted up 3 units. That's it, just by looking at the equation. We've done this with quadratics. And I'll put a Desmos video, quick one up there for you that you can play around with, a link to one where you can see how the graph shifts quickly with a computer graphing software.